Okay, I am going to teach you a new method of factoring today. Okay, now we can factor a difference of squares. Okay, we've done that since Algebra 1. But now we're going to be able to factor a sum or difference of perfect cubes. Okay, so we have factored a difference of squares. Now we're looking at cubes. Now, all of these, I have provided you with a list of our perfect cubes from 1 to 20. Okay, now these numbers get a lot bigger, a lot faster. Okay. Three letters. O, S, I.
These two keep making me laugh.
No, you're aggravating.
Okay, here we go. I've already been texting with Mahler today. Don't make me text him back about something else. Okay, now, those of you who have been with me in pre-calc, you've already done this, so you have a one-up on folks. So make sure that you're using your knowledge to help those around you and not distract. Okay? To factor a sum or difference of cubes, we're going to use what we call the SOAP method. Okay? The SOAP method. Now here's the SOAP method. Same, opposite, always positive. Okay? Same, opposite, always positive. Now, this right here is all about my signs. Setting my signs up in my factorization. Okay? I feel like factoring a sum or difference of cubes, it's really more about just getting our signs in the right place than it is about like going through this whole process of factoring. If I can break two things down, I'll have everything else I need, okay? Now, right here, what I want you to see is that for a sum of squares, in the first set of parentheses, I have a plus sign. That is the same sign that I just used. But it is followed by a minus sign. A minus sign is the opposite of the plus sign. And then in the back, it will always be positive. Okay? Now, for my difference of cubes, I'm starting out with a minus sign, like I'm given a minus sign. So in my first set of parentheses, I'm going to have a minus sign. It's going to be the same as what I was given. Then I will swap to the opposite sign, which is a plus sign. And in the back, it will always be positive. Okay? Now, right here, these right here are my perfect cubes. All I need to do to get going on writing everything out in factored form is I just need to take the cube root of that factor. Okay? So if I take the cube root of a cubed, it's just a. You're basically asking yourself, what is it that I multiply by itself 3 times in order to give me a cubed, or whatever the number is, okay? Same thing with b cubed. Now, when I factor it, I want you to notice that I have a short set of parentheses, and then I have a longer spaced out set of parentheses for both of these. So, short set, long set. We are always going to take our cube roots. We are based on their position, so the cube root of a cubed was a. That's going to go in the first position of my little parentheses, and then b. Okay? You take what you have cube rooted and you drop it in that first set. Now in the back set, okay, this will get easier as we do other problems, okay? In the first position of the long set of parentheses, You take whatever is in your first position and you square it. That is a with a square around it to the second power. And then back here, whatever your b value is, okay, whatever that was, I'm going to take that and I'm going to square that and put it in the very, very back position. And then what do you see that's in the middle right here for both of these? You just have AB. What does AB mean? Yeah, A times B. All you're going to do is multiply your two things together and put it in the middle, okay? I promise, this is a lot easier than it looks, okay? All we need to remember for this is same, opposite, always positive, and you're good, okay? Now, what I see right here for this very first problem is that I've got 27y cubed, which is a perfect cube, and I've got 8, which is also a perfect cube. So I'm going to start out by taking the cube root of 27y to the third power. Now, what is the cube root of 27? 3. And what is the cube root of y to the third power? Why? You're just undoing the cube. You kind of know how like square rooting and squaring are opposites or inverses of one another? Cubing and cube rooting, okay? They just cancel each other out. All right? Then I also want to take the cube root of 8. What is the cube root of 8? 2. 2 cubed is 8. 3y, quantity cubed, is 27y cubed. Okay? Now, to factor this, I'm going to set up a short set of parentheses and a long set of parentheses. Okay? Now, this was a what? A sum of cubes. So I'm going to start out with the same sign in my first set of parentheses. Put your phone up. Phones don't need to be anywhere else, okay? Thank you. All right, now, what do I put right here? The opposite. The opposite of addition is subtraction. And then in the back, it will always be positive. Same, opposite, always positive. Okay? Now, this 3y and this 2. Since the 27y cubed was up front, the 3y has to go up front. And since the 8 was in the back, the 2 has to go in the back. Grab the door for me, please. The snack cart is here. Okay, sorry, I forgot to hit record again. In my back set of parentheses, okay, I'm going to take what was in my first position and I'm going to square it, okay? Everything in the back gets squared, not cubed, okay? What was in the last position is also going to be squared. It's going to go in the very, very back. So I'm separating them. The 3y squared gives me 9y squared. And what is 2 squared? 4. Okay? And then in the middle, I'm just going to take the 3y and the 2. I'm going to multiply them together to get my term right here, which is going to be 6y. And that is factored completely. Okay? All right, I want to do this other one that's a sum of cubes. Okay? So I've got these perfect cubes. I got 216c cubed. What is the cube root of 216c cubed? 6c. Yep. And what is the cube root of 1? 1. All right, so I've got my cube roots. I am now going to set up my short set of parentheses and my long set of parentheses. And my signs here are same, opposite, always positive. The same sign is going to be a plus sign. The opposite is going to give me a minus, and a plus sign in the back always. Okay? Now, the 6C and the 1. The 6C goes in the first position. The 1 goes right here. Now I'm going to take the 6C and I'm going to square it. And I'm going to take the 1 and square it. That goes in the first and last position of my longer set of parentheses. What is 6C squared? 36. C squared. Then I got 1 in the back. What am I going to do to get the middle? Multiply 6C times 1, which is just 6C. Okay? Now let's look at this one. This is a difference of cubes, gentlemen. The cube root of x cubed is x, and the cube root of 125 is 5. Okay? All right. Short set, long set. Now, because this was a difference of cubes, my same sign is going to be subtraction. The opposite will be addition. And in the back, it's always positive. Okay? Now I'm going to drop the x and the 5 in that first set of parentheses. What am I going to do to x right here? So x squared. What am I going to do to 5 back here? Square it. That gives me 25. And then what am I going to do to get this? Multiply x and 5. So I'm going to write this as 5x. You good with that? Okay. All right, here we go. 64a cubed minus 343b cubed. All right. These are bigger numbers, but that's okay. What do you cube to get 64? 4. And then I'll just tack that a onto it. And then I'm going to take the cube root of 343b cubed. And what does that give me? 7b. Okay? So I've got a variable in the front and a variable in the back. That's fine. I'm going to get my short set and my long set of parentheses set up. Same, opposite, always positive. Same, opposite, always positive. Okay? Now I'm going to drop the 4a in the front and the 7b in the back. Now 4a, what's going to happen to the 4a right here? It gets squared. You got to square the 4 and the a. So 4 squared is 16. So this is 16a squared. And then what will I have in the back? 49b squared. Okay. Now here, I'm multiplying these two things together. So 4 times 7 is 28. And then you'll just attach the AB. So no matter how many variables it has, it's fine. Okay? No matter how many variables it has, it's fine. Okay? All right, we're going to hop, skip, and jump through a lot of these. I'm not going to do many of them, okay? But I just want to point out that sometimes when you think you're done factoring, you might have a little bit more to do, okay? The first thing we always want to do is see if there is a GCF, okay? Now, I know that I can divide out a 4y squared here. That leaves me with 4y squared minus 9. Okay, I took out the GCF, but what I want you to see right here is that this is a difference of squares, and that factors more. So the 4y squared stays out front, and since it is a difference of squares, okay, they're going to factor where we have a plus in one and a minus in the back. Okay, right here. This is a difference of squares, so plus and minus in one or the other. The square root of 4y squared is 2y, so that goes in the first position. The square root of 9 is 3. That goes in the back position. Now that is factored completely. Okay? Whoops. Okay, right here. We do not like negative leading coefficients. So I need to divide out a negative 2. This gives me x squared plus 15x minus, plus 72. Yep. Now, if you go, so right here, you've got a trinomial that you need to try and continue factoring. If you go and you list your 72 on the top, and, that should be a negative 15, and a negative 15 right here. If you go through and you list out all your factor pairs, so I got 1 and 72, 2 and 36, and then you go through all of those, okay? You will find that there is no two numbers that multiply to give me positive 72 and add to give me negative 15. That means that this part is prime, but we cannot call the whole polynomial prime because I was able to factor out that negative 2 in the beginning, okay? But that would be factored completely. All right, let's look down at the very bottom right here. Actually, I'm going to do this one. Yep. Okay, so right here, I can take out a 3a squared to begin with. This leaves me with 2a to the 8th plus 5a to the 4th plus 3. Okay? Now, these are much higher exponents than I've been working with. But what I want you to see is that my power 8 right here, if I cut it in half, it gives me 4. Okay? If your power is cut in half right here, you can factor this like you would a quadratic. Okay? So I can do the x method here. I'm going to do 2 times 3, which is 6. And you need those factors to add up to give you 5. Now, it has to multiply to give you a positive 6, and it has to add to give you a positive 5. So both of your numbers have to be positive. 6 and 1 will add to give you 7. 3 and 2. So 3 and 2 go on the bottom. Now, what goes on the top? Okay, right here, we've got to put 2a to the 4th power. We're going to use our power that has been cut in half, because what is a to the 4th times a to the 4th? A to the 8th. But if I add a to the 4th together, it still adds to give me a to the fourth. You don't change anything when you're adding, okay? Now right here, 2/3 does not reduce, but 2 over 2 does. That becomes 1 over 1. So my completely factored polynomial here is 3a squared times 2a to the fourth plus 3 times 1a to the fourth plus 1. Now, if you were in pre-calc, you would not be done yet. This right here could be factored 2 more different times. Okay? All right, here we go. On the back, okay? These right here, you do not factor them any differently, okay? 1 times 49 is 49, and you need those factors to add up to give you negative 14. You should see that that's negative 7 and negative 7. You got 2 things that were the exact same. So I have y minus 7 times y minus 7. Well, y'all, if I have the same thing, can't I simplify that? You can write y minus 7 to the second power. This is completely simplified. You want it in simplified form, okay? This one would be m minus 9 squared. All right, I want to look at this one right here, okay? 4 times 9 is 36. And you want the sums to add up to give you negative 12. That should be negative 6 and negative 6. Well, what do you know about 4 and negative 6? What can I divide out of those? 2, so that's going to be 2 over negative 3 for both of them. So y'all, I end up with 2a minus 3 squared. You have 2 or 2m, whatever your variable is. Sorry about that. 2m minus 3 squared. Okay? Now, do you see these were the same thing, right? These were the same thing. They multiplied to give you 49, but they added to give you 14. If I take this negative 14 and I cut it in half, that gave me these negative 7s that I multiplied together to get that positive 49. Okay? Now, I want to know, what would the number have to be in the back to make this a perfect square trinomial? All of these right here, all of these things are called perfect square trinomials because they factor into something that I can square. Okay? So, this number right here, y'all remember, that was on the bottom. I am looking for the number that would be up in the top. So what did I just do? What would I do to that negative 14 to get those negative 7s? You cut it in half. So cut it in half, that gives me negative 6 and negative 6. If I multiply those two things together, I get 36. So what we're doing here, we're taking our middle term, we're cutting it in half, and you're squaring it to get that number that goes up here. All right, so this one, if I take the 8 and I cut it in half, that gives me 4. And then I will square 4, and that gives me 16. These are the numbers that I was looking for to make that a perfect square trinomial. Done. Okay? Now, I just factored this one. Okay? I literally just factored this one. Also, change this m squared to a y squared. Sorry about that. Okay? Just change that to a y. Now, when I factored this, okay, I did the 4 times 9. That gave me the 36, the negative 12. Here, I had 4y, negative 6, negative 6. And both of these factored into 2 over negative 3. So 2y minus 3 squared. My question here is, what are the values of A and B to complete this statement? Now, first of all, I want you to pay attention that this minus sign is going to be the exact same thing as that minus sign, okay? So you only need those numbers. That's going to be 2. And since these negatives are the same thing, I'm only listing a 3. Okay? Now, this one will factor. When you do all that stuff, it should factor into 3y minus 4 squared. 3y minus 4 squared. I scratched this out. I accidentally put that in the wrong place. Okay? So what's my A value here? 3. And what's my B value? 4. Because that negative is the same thing as the other. Now, what if this had a plus sign in it? What would I then say for my B value? Negative. You would have to put the opposite. Okay? All right. All right, solving polynomials. Okay, y'all are going to like this in a minute. Okay, but I want to start out and I want to remind you that when we are solving polynomials, we have to make sure that they are set equal to 0 to begin with. Okay, we are trying to find the solutions where my graph crosses the x-axis. Okay. So right here, I want to take this factored form. This one's already set equal to 0. And I want to rewrite it in factored form. And then I want to give the solution set. Okay? Right here, I'm going to factor this. Now, the factors of 45 that add up to give me negative 14 are negative 4 and negative 9. No, negative 5 and negative 9. Sorry. Negative 5 and negative 9. That's how this factors, okay? So I have rewritten it in factored form. This is part A. Now, for part B, if I want to find the solutions, if you recall from Algebra 1 and Algebra 2, this is where you take your factors, you break them apart, set each one equal to 0, and you solve for x. So right here, x equals 5 and x equals 9. So that's where the graph is going to cross. But if I write it as a solution set, I'm writing it in set notation, and I'm listing my factors. So factored form and set notation. Okay? Now this one, it's not set equal to 0, so I need to rewrite this real quick. I am going to bring this negative 24 over to the other side so that I can set that equal to 0. Now when I go through my process and I factor, we should find that we get x minus 6 and x minus 4. Do you agree negative 6 times negative 4 is positive 24? But negative 6 minus 4 more is negative 10? This is part A. This is factored form. Now, my solutions, if you take each one of those and you set them equal to 0 and solve, here you get positive 6, here you get positive 4. So my solution set is the set of 4 and 6. Factored form, solution set. Okay? Now I want to show you something. Now I know in the video you won't see what I'm about to do. But I'm going to type in the polynomial as it was given to me on the original equation. So x squared minus 10x equals negative 24. What am I given right there? Your solutions. Okay? So you can use Desmos to help you out with that also. Okay, now I want to do the next one with Desmos. Okay? I'm asked to solve x squared equals negative 5x minus 6. Okay, I've got my two solutions right here. So part B is already done. My solution set is negative 3 and negative 2. But I got to get back to factored form to complete part A. My solution was x equals negative 3 and x equals 2. If I take those factors and I move them back over on the other side, oh, y'all can't see that. I'm so sorry. Ain't nobody telling me either. Okay? My solution set was negative 3 and negative 2. So x equals negative 3, x equals negative 2. If I want to write this in factored form, all I need to do is move this back over, move this back over, and here is factored form. That's part A. Okay? Thank you, Desmos. Okay? Yeah, you can do the rest of those. Now, I will tell you, Desmos only recognizes the variable x. So if you're given another variable, just change it to x for the problem, okay? Y'all have a great day.